Hello everyone. I'm currently pursuing my BTech in Information and Communication Technology department, and I am in semester 4. So welcome to this video tutorial of statistical analysis tool. For this video, I am exploring the tool which is JASP, and it is developed by the University of Amsterdam, and it is totally free. You can download it from their website, and I will be also put the link in the description to download this software. So let's do not further waste time and explore the JASP software. So it is the first slide that we will see when we open the JASP software. For this video tutorial, I am using the JASP version 0.14.1, and there are several reasons we are using this tool. Like, it is completely open source and free for everyone to just do their statistical analysis, and it provides robust features like we can do the various statistical analysis like graph plotting, frequency table, etc. We can do the linear regression. Also, we can perform the test like binomial test, etc. There is also a feature called R. So we can directly write the R command is like we write in the R studio, and we can do our analysis. And the main feature is like we can easily export the results in terms of allowable type, or we can simply just copy our results of graphs and paste it whenever you want. For example, like we can simply paste it in Word where we are writing our report or something like that, right? So let's start. So to do the statistical analysis, we need some data resource. So here I am using the open source data. So let me open this. So it is the Excel file which I have downloaded from the open source. It is the data set which contains the two columns: height, the person's height, and its foot size. So I will be also putting the link of this Excel file in the description. You can download it, and perform the various statistical statistical analysis. So in JASP, it does not provide the direct support of Excel file, and it is not natively supported. But what we can do, we can simply save this file as .csv file, and that we can open that CSV file into the JASP software. So simply we will do the save as here, and we can name it as server CSV file. And we can save it as the CSV comma delimited, and we can simply do save. So now it is saved as a .csv file. We can directly open it .csv file in the JASP. So here is the menu. You can open, do save, save as, export results, export data, sync data, close. This all options will be enabled once we open our data. So let's simply do the open. There are multiple options like recent files, computers, OSF. You can directly open your account in OSF and save that data, or open that data from their database. They also provide some data library here. So let's open our data from computer, browse, and we will open this survey CSV file. So now our data, which is we have seen in that CSV form, is now open in our JASP software, right? Now here, there are multiple methods by which you can perform your analysis. These are some methods. So yeah, let's start exploring tool. So let's see first of all this feature, which is a filter. Let's see how it is work. It is simply but simple. You can directly drag and drop the values. For example, I want to find the height equals to, let's say I want to find the height which has value as 65. So we can write height equals to 65 and do the apply pass-through filter. So as you can see that height which has 65 value, which are now shown, or we can say the highlighted over here in the data, and filter which you have applied in that column, it will show that filter icon, right? So all the 60, all the rows which have height as 65 will be highlighted. Also, there are multiple features like mode, sigma y, sigma square y, summation of y, then minimum, maximum, mean, round, length. All you can perform. Simply drag it and drop it. And also you can delete that also. So it is now deleted, and also I have cleared this filter. So let's close it. So here are the our data set, right? And if you want to do the changes over here, for example, there is second column, height is 66 and foot is 9, and I want to change this value. So what I will do, I will simply double click on the file, so it will open directly the CSV file, and we can do the changes over here. Like for example, I am changing 9 from 9 to 12, and simply what I will do, I will save it. So now it is saved, and once we open the JASP, it will automatically change over here. So changes will be reflected automatically over here. So here total 199 data are there. Now let's start our analysis by the first method, which is descriptive. So once we click on that descriptive, the entire window will change. Now the left side we will do the operation, and the right side we can see the results. Okay, and we can also drag it to see the data and change if we want to do, right? So let's start. So this shows all the column. Here all the columns will be displayed, and the descriptive statistic we want to perform should be here in the variable. You can simply drag it from here and drop it. So the result of descriptive statistics will be display over here. Also you can try with this button. So foot will be now the variable section, and also you can see it's so here in this table it is showing valid 199. It means that we have 199 valid data, which we have seen that we have total 199 data. So all data are valid and missing is 0. So not any particular cell is containing 0 value or null value. So all data are valid. You can also find it from here, and its mean value will be displayed, which is nothing but arithmetic mean, like sum of all the values divided by total number of data, which is 199. Same as for height and foot. Standard deviation will be also displayed. Minimum value like 52. So if we look into the height column, the minimum value which can be shown is 52, right? And the maximum value which is 80. Same as in foot, minimum value is 6 and maximum value is 16. So you can see the descriptive statistics table over here. Now the next part is frequency table, but it is mentioned in the bracket that it is only applicable for nominal and ordinal variable. So nominal and ordinal variable is nothing but variables, types of variable, or you can say the level of variables. So here you can see that height is now scale. So to display the frequency table, now let's make it the nominal, same as foot. And once we click on that frequency tables, the frequency tables are displayed. So for height, all the values are in ascending order. The frequency will be shown like 52 comes one time, total percentage like total 199 data, and 52 comes only one time. So its percentage will be displayed, and the valid percentage like after rounding off, and the last is cumulative percentage like sum of. So it is 1.503. So the cumulative will be 0.503 plus 0.503, which is 1.005, right? The same is cumulative percentage will be displayed over here. And as we know that the last value of the cumulative percent will be also always 100%. So which is also can be seen here. Same as for food, frequency, percent, valid percent, and cumulative percent are displayed here. So it is the frequency table. Now let's see the plots. First of all, deselect the frequency table. Now let's see the plots, and let's make it our height and weight as again as a scale. So let's see the plots. So the first thing is color palette. We will see once we plot the various graph, and then we will change this color palette. So there are basic plots like distribution plot. So once we click, you can see the distribution plot for the height as well as for the food. So these graphs are simply you can increase or decrease its size as per your needs. So in x-axis it's height, and if y-axis it is count. So it is similar to bar graph only. So for height and food, the distribution plot will be displayed. Also, you can display the density in the graph. So the center values, the line will be passed, and the next graph is correlation plots. So the correlation plot will be displayed like for height and for food. The next is QQ plots. QQ plot is nothing but a scatter plot, which is generated by plotting the two quantiles, height and food. So you can see these QQ plots also. QQ is nothing but quantile plots. And also you can plot the pie chart. It is a refreshing for pie chart. Let's again click on pie chart. I think there are too many results in the result section, so that's why pie chart is not. Okay, so for pie chart, we need to change our variable from a scale to the nominal. So let's make the height and foot as a nominal. It is the level of variable, you can say. It is refreshing our results. Now, when we click on the pie chart, pie chart will be displayed, and its annotations like which color displayed each result. Also, we can change the color palette also from that color blind to, let's say, this. So the color will be also changed, and you can select this color palette as per your need. Let's make it the default only. Okay. Now, let's move ahead for the box plot. For box plot, we have to make it scale. Now, let us see the box plot. So here we can see that box plots like minimum is 55 for the height and maximum is 80 height, and two quartiles are displayed over here. You can also add the violin element, like violin shape of box plot. You can also add. You can change the color palette and select this option so that your box plot will change its color as per your need. And you can also add the jitter element also. So this is the box plots. Now let us see that scatter plots. So here is the scatter plot where x-axis displays the height and y-axis displays the foot. Here you can have multiple options like graph about scatter plot will be dense or in terms of histogram. So it will change according to this. You can see that as a histogram, or you want nothing. So you can simply select the none. Also, you can select these graph right of scatter plot these things and dense in histogram, or you want as none only the scatter plot. So you can select that none. Also, you can select this is the blue line is the regression line, as we know in regression. So you can also select that you want regression line or not, and if you want regression like it should be a smooth or it should be a linear regression line. So you can select from these options. You can also change the confidence interval, like how many confidence interval you want. So for example, it is by default 95%. You can also change it to, let's say, 98%. According to changes will be reflected in the result section. So this is the plots like where you can plot the different graphs of distribution plots, correlation plots, pie charts, scatter plot, box plot. So these all features provided by the JASP natively. Let's close this plot and let's move on for the statistics. So here statistics is, as we know that central tendency, as per central tendency theorem, there are mean, median, mode. So we can select that in the first table that we have seen earlier. Here the mean is displayed. If you want to display the median also, then you can select this checkbox. So it will display the median. It is nothing but the middle value of all the data. So for median, median of height is 67 and median of foot is 10. You can also select the mode, which will display the which data comes the maximum times, or we can say the frequency of that data will be maximum. So 67 comes many times, maximum times, and for foot 9 is for maximum times. Or also you can display the sum, like sum of all heights. 199 data heights will be added, and same as for foot. All other, you can also add the quartiles. So by default, the cut points for is 4 equal groups. So it will be divided into 4 equal groups, like first to 25th percent, 25th percentile, 25th to 50, 50 to 75, same as 50 to 75 to 100. So it will be divided into the four quartiles. By default, it is 4. You can change it to over here also. Like if you do not want equal 4 group, you can make it equal 5 group and press enter. So it will show the equal 5 groups interval. So it is for percentile values. The next thing is dispersion. Like you can also plot the standard error mean, which is nothing but sigma upon root n, where n denotes the total number of data, which is 199 in our case. So you can see here standard error of mean for height it is 0.342 and for foot it is 0.129. Also there are multiple parameters like MAD robust, IQR. You can also plot the variance, which is square of standard deviation. So the variance will be reflected in the results. Here the variance. And you can also see the range. Range is nothing but maximum minus minimum. So for height, maximum is 80 and the minimum is 52. So the range will be 80 minus 52, which is 28. And same as for foot, maximum is 16 and minimum is 6. So the range will be 16 minus 6, which is 10. So that's how you can do the statistical analysis, or better we can say the descriptive statistics module, right? Now the question is, we have performed statistic analysis, right? And we have find this many graphs, or we can say the results. So how we can store these results? So there are different options, like you can export the result here. You can do the export results as computer in your computer only. So you can save, or you can save or export this result in the OSF. You can create their account, and then you can use their functionality. Or the other options are, you can save it on your computer. Like we will see that and how you can store that. But first we will see that what we will do with that result. You can edit this title as well, like it is a result of our survey. You can simply add this, and you can also add note over here. Is like it is a result of our statistic analysis, right? Same as you can add or add title, or you can give the notes also. And one of the feature is copy citation. Like if you are writing some of the report and you want to give the citation, then you can directly copy this citation and use it whenever you want. Now let's see that how we can export this entire result, right? So we can simply do that export results. So it will ask that where we want to save. Like I want to save in this folder only, and I can file it as, name it as result, and you can store it as HTML or PDF, whatever you want. Like I'm storing it as a .pdf file. So it will take some time and store my all the results, or like these tables and the graphs in the form of PDF. So let's wait for 1 second. Yeah, so our is stored, and you can see that result PDF is now here. So you can open it. So that these results of our survey file is ready with all our graphs and tables. Also, the one more ready to go thing is, like you can simply copy this entire thing. So it will be copied to clipboard, and if you are writing that report, then you can directly uh, copy that report into the Word file. Like for example, I'm opening Word. Blank document, and simply I'm pressing Control V, because we have copied that entire thing. So all the result will be copied into the Word file, and you can use these graphs and tables in your report. So it is the one more feature of JASP, that you can easily export or save the data. So we have seen that first module of descriptive part, right? Let me close this. Now the next module is t-test. You can perform the independent sample t-test, paired sample t-test, one sample t-test, and there are two options, like you want to do the classical analysis or Bayesian analysis. Bayesian analysis is nothing but it follows the, or it follows the Bayes theorem. So it is called the Bayesian analysis. The second module, you can do the simple test. The third module is ANOVA, which is nothing but analysis of variance. You can do the analysis of variance, or analysis of NCOVA, which is analysis of covariance. You can do all these things with two approach, classical approach and Bayesian approach. The next module is mixed models. Like you can do that classical and Bayesian linear mixed models and generalized to linear mixed models. So these are some statistical analysis methods by which you can do your analysis and find your results. The next thing is regression again, where correlation, linear regression. Let's see the correlation. First of all, let me make it more clear. Okay. Now here you can put like I want to my variable is let's say foot and I need condition on height. So it will do the correlation and the result will be displayed over here. But here you need to make sure that you need minimum 2 variables, right? So you can do this correlation. You can also see here some of the options which you can use. So let's close this form. The next thing is frequency distribution, like binomial test, multinomial test. So let's see the binomial test. So we can here we need to have that nominal ordinal. So let's make it nominal variable. So the binomial test will be performed over here. Here you can select the test value. By default, it is 0.5, and you can select the alternative hypothesis, like it is not equal. Your alternate hypothesis is not equal. It should be a greater than, or it should be a less than. You can select from here. You can also select your confidence interval. So in binomial test, it will provide you the levels like 52. It comes, its count is 1. Its proportion out of 199, and its probability will be displayed. So it is the binomial test. Now let us see that next one is factor, which is principal component analysis, exploratory factor analysis, and confirmatory. Also, these are some methods by which you can do your, or you can say that perform your analysis. Okay, this error because in descriptive statistics you need to scale. Let's make it scale. Also, there are some other methods also in JASP. You can simply click on this plus, and these all are other methodology by which you can do your analysis. For example, audit, Bain, distribution. So let's see that distribution. When you click on that checkbox, it will be added to your main screen. Let's see that in distribution, there are two options: continuous distribution and discrete distribution. In continuous, there are normal, like a normal distribution, chi-square, inverse, gamma, exponential, and in discrete, it is Bernoulli, binomial, Poisson. So you can perform that distribution. For example, let's see that normal distribution. So when you click on that normal distribution, the probability density function, that is PDF will be displayed in the result section. Here you can select your parameter as mu, mean, and sigma square, then mu and mean and variance, mu and standard deviation, mu and t, mu and k. And by default, the mean value is 0 and variance value is 1, which means we are performing the standard normal distribution. If mean value is not 0, then it is not standard normal distribution, right? So also there are some options like experimental text. You can select from here. There are other options too. So this is the normal distribution function. Now let us see that some of the discrete distribution function like Bernoulli, binomial, Poisson. So let's select the Poisson. So it will display the Poisson's probability mass function. Here you can see that, as we know that Poisson's formula contains a lambda. So you can select here the lambda value. So the PMF will be displayed for the probability for x equals to x. Then there are Bernoulli's Bernoulli's. So for Bernoulli's, probability mass function will be also displayed here, and there are binomial distribution. So the PMF for the binomial distribution will be also displayed over here. Here you can change that probability of success. By default it is 0.5, so equal probability for each outcome to appear. And you can change the number of trials in. By default it is 10. You can change all these parameters according to your need. Let's see that the next thing is negative binomial and Gaussian, like Gaussian we have seen. So it is the distribution model. Now let us look into the other modules like equivalence t-test, GAGS. It also provides the support of machine learning. So in which it is very robust feature. You can do the regression, classification, or clustering. For example, you can train your model by giving some data set, like if X value is this, then Y value should be this. So you can train your model, and then after that, when you provide some value of X, it will give you the predicted value. So it is very robust feature of JASP. You can do the machine learning model. You can train your model. And the next thing is meta-analysis, network, reliability, same, which is structural equation modeling, and summary statistics, visual modeling, learn based. So these are modules that you can use for your need. The last module is R, which is in beta form, but it works well with your R command. So it is nothing but when you click on it, this window will be open. R engines. Here you can write your code same as we are writing in the R Studio code. We can use this as a R with R analysis, R Studio analysis, right? So let's see that descriptive first. And okay, now how we can operate in R. Like for example, I'm writing data. So all the data like these data will be displayed in terms of height and foot. So that you can use this data command for displaying all the data. Also, there are some functions like mean in R. So if you want to find the mean, you can simply directly write mean. Then you need to write data dollar, and you can write your variable length. For example, I want to find the mean for the height. So I can write data dollar height. And when I click on the run code, it will give me the mean for height, which is 67.690, which is same as we can see here in the table, 67.691. Also, we can find the mean for the foot by writing mean data dollar and the variable name, which is foot, that in this two, and we can do the run code. So this is 10.165, which is also here. You can see in the foot mean is 10.167. There are several other commands also. You can type it in this window, and it will work as same as your R Studio. Like in which in R Studio we are writing our R codes and do our analysis. That same thing you can perform over here also. So it is the R model. Again, one of the robust feature of this JASP software. So yeah, this is overall the tutorial for the JASP software, open source and free statistical tool by which you can perform your analysis. So yeah, that's the video. Thank you for watching this video.